Hi everyone, I continue with this part is configuring a particular interface. When you need to configure a particular interface, just enter the interface name at the configure prompt. The router will place any further statement under the interface configuration. And I need enter the command enable no config terminal enter. Okay. With the command int of interface and the name of the interface s10. Invalid interface type and number. Okay, show interface invalid output detected. Okay. Well, gigabit. I have the gigabit Ethernet 0/0/0 is administrative downline protocol is down disable hardware okay. Gigabyte Ethernet 0/0/1 and finish with Gigabyte Ethernet 0/0/2 and I have one VLAN. Okay. In physical in configuring gigabyte, gigabyte 1, gigabyte 2 and VLAN. Okay, back to the clear switch and int okay. Okay. Mm, Gigabit Ethernet 0/0/0. Okay, note that the prompt changes to router conf if to remind you that you are configuring an interface, not the entry router. Why is this important? Do you remember our example configuration that had no IP redirects on a single interface? Presumably, that router needs the features enabled on some other's interface on a global level. Enabling and disabling features and protocols on a per interface basis gives you fine-grained control of your router. Routing protocols have a similar configuration subprompt. Okay. And router BPG. Okay. Any further statement will appear in the router BGP 8292 section, as shown in our example earlier. If you want to stop configuring a particular interface or protocol but remain in configuring mode, use exit. Okay. I use exit and exit. Saving changes. Entering this configuration statement will alter the running configuration, but that configuration won't persist through a reboot unless you save the configuration. For example, copy running config state startup config. Again, all Cisco hands might remember this as write memory or WRMem. Cisco hasn't taken that away from you either. Okay, for copy the configuration of running to a startup, you put uh, the code, copy, running config to a startup config. Okay. Destination field name startup config. Yes. Destination file name startup config. Yes. Copying and yes, invalid argument. Okay. Again. Okay. Only with enter. And backing of router configuration. Router configuration are just plain text. The simplest way to back up your router's configuration is to copy the configuration statement to another system, perhaps a plain text file on a server or even to a piece of paper in a long book. Show your router suffer a critical failure and lose its mind. You can restore service by just going into configuring mode and pasting in the empty router configuration. If you have unlike Unix-like system available, programs such as Rancid automate configuration backup. It is also possible to copy your router's configuration to an FTP file transfer protocol server with the copy FTP command. The process is quite similar to the FTP process used for iOS upgrade, and it is an excellent precaution to take before an upgrade, so we discuss in the chapter 6. The next is router interfaces. One of the main functions of a Cisco router is to connect different types of networks. Connecting Ethernet system is quite straightforward, and connecting WAN links is just as easy. But these two very common network types simply refuse to talk to each other without an intermediary. The router allows you to treat very different physical networks as a single, continuous entity. Cisco router supports almost any type of network interface: Ethernet, serial, token rings, DS3, OC3s, synchronization modem, and so on. This interface might be on not one card that slides into a system, much like those used in a laptop, or that might be integrated with the system. And when some bridge scientist develops direct neural links into the human mind, Cisco will have an interface for that too. But until then, the most common interface types are Ethernet and serial, so we focus on them. But interface? By looking at the system interface, you can see not only what sorts of interfaces the router has, but also how much traffic each interface is handling, what sort of network errors the router sends, and a whole slew of further details about the networks the router is attached to. To see every interface on your router, type show interface. Every interface on the router will show up with an entry starting this like. Okay. Enter the command show int through interfaces. Okay. Mm, okay. I have four interfaces: 3 GB Ethernet and one VLAN. Okay. And routers list their interface by their internal order in the system. Some routers clearly print this order on the chassis, while you might wonder where other routers learn them to count. Each interface is uniquely named by a type, fast Ethernet in this example, and a unique number for that type. In this case is 1/0. The first interface of any type is numbered 0. A split number like the one in this example tells us that multiple interfaces are loaded into a single module or card. For example, the interface Ethernet 1/0 is the first Ethernet interface on card 1. Numbering depends on how the router thinks that interfaces are attached. On a router with many interfaces, you might only want to see a particular interface. For example, if you want to see if your internet circuit is working, you only need to look at the interface that's connected to that circuit, not every interface on the router. To display a particular interface, add its name the showInt command. For example, to see only the interface serial 0, enter showInt serial 0. Okay, enter that command show interface uh, serial 0. Okay, invalid input detected. Market. Giga 0. One. Okay. Gigabit Ethernet 0. Okay. Sorry. Okay. It's administrative downline protocol. Okay. And well. Mm, with commands, you can abbreviate interface names to the shortest unique identifier. This abbreviation usually contains use and no letters to uniquely identify the interface type and number. For example, serial 1 can be S1, Ethernet 0 can be A0, and fast Ethernet 2/1 can be fast 2/1. Have a look at your router's interface names to see how they can be abbreviated. Okay, in my case only I have 4 interface, 3 GB and 1 VLAN. The next is common interface characteristic. When you run showInt on most types of interfaces, including serial and Ethernet, you will see a great deal of similar information in the resulting output for each. The example below shows the first part of showInt output for an Ethernet interface. but everything we discuss relate to serial interface as well. Okay, show it Ethernet. Well, and well, show it. I entry the code. Show interface gigabit 0/0/1. Okay, and here start. Well, the output from each interface continues, but is mostly debugging information and not useful at the moment. We look at that additional output in Chapter 5. Looking at the output above, we first see that the interface is up. This means that a physical cable is plugged into the interface and that the router sees a comprehensible signal from it. If the interface is unused or empty, or if there is some physical problem with the circuit, the status will be down. If your interface is up, chances are good that there is not physical problem with this network. Okay. If it is down, the problem can quite possibly be identified by walking along the wall looking for problems. In the case of serial lines, however, that wire might be very long. Okay, this in the point 1. Fast Ethernet is up. In my case, Gigabyte Fast Ethernet is administrative down. In my case, is down because I don't attach never cable. And continue with the point 2. Next is the line protocol status. The line protocol tells us if the router understands the encoding used by the signal coming over the line. Every network type uses some sort of physical protocols that encode the actual data into a string of ones and zeros, as long as the device on the other end of the wire uses the same protocol as the router interface. This line should read up. However, even if you have a working circuit plugged into your router interface, if the router on either end are using different line protocol, the status here will read down. A usable circuit must have both an up circuit and protocol agreement. If your circuit is up but your protocol is down, your configuration is probably wrong. At one end or the other, the line protocol is set in the encapsulation section described in point A. And I repeat, a usable circuit must have both an up circuit and protocol agreement. If your circuit is up but the protocol is down, your configuration is probably wrong. Okay, in my case, is next is point 2. Line protocol is up. Line protocol is down, disabled. Okay, it's the same case. I don't have plugin, never cable in that port. The interface reports the sort of hardware this router is using for this connection. This is the point 3. This name is frequently some obscure Cisco or internal part number of name, but it might include a description of the part. Unfortunately, there is not publicly accessible master list of this part, but if you are familiar with the technology, you might be able to glean some useful information from the hardware description. In this example, we have the fast Ethernet port's MAC address. Is the point 3. Is hardware is AMD feed address Okay, in my case, is hardware is is3. Okay, address is this. And the interface reports the sort of hardware. Okay, in this example, we have the fast Ethernet port MAC address. Okay, address. In my case, this is my address. So you can enter whatever you like in the description field. While this might seem pointless for a usual Soho network with just one interface, it can be very helpful to enter a plain English descriptive name here when your router has multiple interfaces of each type. On serial circuits such as TAs or DS3s, it recommended putting the telco circuit ID in this field. We'll discuss circuit IDs in chapter 4. Okay, point 4. Description: my office Ethernet hub. In my case, uh, okay, I don't have description. Okay, and the next is this. Every configured interface has some basic TCP/IP configuration information, such as an IP address and net mask. We see how to configure this later this chapter. This is the point 5 internet address. In my case, mm, encapsulation, output. Okay. Uh, okay. And the next is here. We have some basic information about the physical protocol spoken on this interface. The standard MTU maximum transmission unit for most devices on the Internet is 1500 bytes. As shown here, if yours is different, someone set it that way for some particular reason. Changing this value will increase the fragmentation of packets that pass through your network and is generally inadvisable. If your MTU isn't 1500 bytes on an Ethernet or TI circuit, that's almost certainly your problem. Big circuits such as DS3 and OC178 have their own proper MTU values, and mucking with these will cause all manner of difficulties. The BW value is the total bandwidth of this interface. Okay, 7. Okay, this can be vital information if you're trying to determine why your router seems to be slow. If your router can handle 10,000 kilobits per second like this interface, and you try to cram twice that amount through your network, you are going to have serious problems. Finally, the encapsulation is the logical protocol used for this interface. In the most basic sense, this tells the router what sort of network you are attached to. In this example, we are using ARPA encapsulation, which is used for all Ethernet interfaces. Serial links have more options, as well discussed in Chapter 4. This is where the line protocol discussed earlier is set. If your line is up, but your line protocol is down, this is probably the setting you need to change. See the chapter 4 for the common encapsulation types. Okay, if your line is up, but your line protocol is down, this is probably the setting you need to change. Okay, encapsulation ARPA loopback not set. Type ARPA timeout. Uh, 1 million of kilowatts. Yeah, that is a connection of gigabyte Ethernet, and ARP encapsulation loopback not set. Okay, and configuring interfaces. You enter configuration information for a single interface in configured mode, as discussed in Chapter 2, but to do so, you must specify the interface that configuration applies to. After you are in configuration mode, enter the interface name. Okay, and I need configure the fast Ethernet and config terminal. Enter the interface as giga 0/0/1, and the conf if Cisco C for configure interface. Label indicates that configuration change you make will only apply to single interface you specify. Every interface is shut off by default. To activate an interface, use the No Shut configuration option. If your interface doesn't work and you think everything is configured correctly, you probably forgot to turn it on. To disable an interface, enter Shut. Okay, I enter not shut. Enter. Interface change state to up. Okay, excellent. And to leave configuration mode, enter Ctrl C. And okay, enter again the code. Show interface gigabit 0/0/1. In this case, line protocol is down, but gigabit Ethernet is up. And is down. Okay, and here is up. The line protocol is down, is disabled. Okay, and Q. Ethernet interfaces. Almost every Cisco router has one or more Ethernet interfaces. Ethernet is a broadcast medium. Many devices can be attached to a single Ethernet network, and information transmitted by a host is broadcast across the entire network Ethernet. Almost all modern office networks are Ethernet. Theoretically, every host on an Ethernet network sees all data transmitted by every. Okay. Theoretically, every host on an Ethernet network sees all data transmitted by every host on that Ethernet. Switches direct transmissions to only the target system whenever possible. Even a top half of the line switch still sends some traffic to all the hosts on the network. If you are having trouble with your local Ethernet, a bad switch or a bad cable is the most common cause. If you are still using a hook, that's almost entirely the problem. Please join to the 21st century at your early opportunity. Be sure to check hubs and switches before you blame your router. While Ethernet has been run over a wide variety of physical media in the past, today almost everyone uses Ether Category 5 cable or some sort of fiber. You might find a antiquated Cisco 2500 with an AUI port, but most of these will also have a team-based Ethernet ports. From the Cisco point of view, all the Internet interface are configured the same way. Just remember that the connection speed will only be as fast as the slower network device on that link. For example, if you plug a 1000 megabytes Ethernet switch into a 100 megabytes Ethernet router, the connection will be limited to 100 megabytes. Other devices on the 1000 megabytes Ethernet can still go up to 1000 megabytes if they have a card that supports it. Here is the beginning of the output from a showing on a typical Cisco Fast Ethernet interface. Let's look at some of the useful Ethernet specific information. Show it, okay, is the same. The first interface things is the MAC Media Access Control address. The Ethernet address, this is the 48-bit number that is in theory unique to each Ethernet device. In practice, some vendors reuse Ethernet address because the change of two devices with the same MAC address within up on the same network are negligible. Because Cisco routers allow you to change the MAC address of an Ethernet interface. They also show the original burning address assigned to the device by the manufacturer in part less. In parentheses, the MAC address and by address match in this case. Okay, the MAC address and by address match in this case. Okay, this is the MAC and this is the by. In my case, this is my, it's the same. Okay. The MAC address and by address match in this case. Active Ethernet interface also show the duplex settings, which is half duplex in this case. The duplex is usually automatically negotiated between the router and the switch it's attached to. An active interface also shows the current network speed. Okay. 3.3.5 duplex. And an active interface also shows the current network speed. By default, Cisco devices auto-negotiate the speed and duplex. You can hard-code the speed and duplex, but doing so can escalate a minor equipment failure into a major one. For example, while your switch might support 100 megabytes per second full duplex today, If one cable has a problem and must fall back to half duplex, your hard-code duplex settings will bring the circuit down. It's better to run in a degrade mode than to go down entirely. Your best bet, if possible, is to allow your router to auto-negotiate its duplex settings unless you already understand the issues involved. If two devices have trouble auto-negotiating, however, you probably must hardcode the speed and duplex. Finally, you can see the type of physical medium connected to this interface. As you can see, this high-quality fast Ethernet interface is connected to a slow high duplex 10 megabytes network device. Configure Ethernet interface. The only change you must make to an Ethernet interface to get it on the network is to give it an IP address. Okay, router config IP address net mask. In most small networks environments, the Ethernet interface IP address is the default gateway of the attached network. For example, to set the IP address to 192.178.1.1 with a net mask 255, you will use the following command: IP address. Okay. After you have this basic configuration, you can go onto a variety of other settings. Okay. Um, okay, IP address and netmask. Okay, enable mode, no. Config, terminal, enter, and interface gigabyte 0/0/1. Okay, IP IP address. I assign the IP with netmask. Bad mask. Okay, yeah. This mask. And again, exit and show interface gigabyte. Sorry, is exit. Okay. Sorry. Exit. Enter. Show interface giga 0/0/1. Okay. Okay, here is my IP address. Well, in description, while entering a description is almost pointless for a simple router with a single TA port and a single Ethernet. The description field is very useful when your router has multiple interfaces of each type. Enter a description with the description keyword. Keyword. Okay. Uh, okay. The description. Sorry, is with config terminal in the int gigabit server one and description DMC network. Mm, okay, again and exit and exit and show interface gigabit. Okay, gigabit. Okay, description. Below of hardware. Okay. Duplex. By default, the router will attempt to auto-negotiate the duplex settings of a connection. You can force a particular setting with the duplex keyboard, which has three legitimate settings: auto, half, and full. Here we force a connection into half duplex mode. You might try this if the router negotiates a full duplex connection to see to be dropping packets or if the commands keeps dropping. Okay. Okay. By default, the router will attempt to auto-negotiate the duplex settings of a connection. You can force a particular setting with the duplex keyboard, which has three legitimate settings: auto, half, and full. Here, here we force a connection into half duplex mode. mode. You might try this if the router negotiates a full duplex connection, but seems to be dropping packets or if the connection keeps dropping. Half duplex. Okay. Is again in configure terminal with int gigabyte 0/0/1 and duplex half. Cisco recommended slaving Duplex at the default settings auto, so the router will negotiate its own best duplex. Okay. Speed. Much like duplex settings, the router will attempt to negotiate the best possible network bandwidth with each switch or hub. You can make the router run at only a single bandwidth settings and refuse to run at other speed with the speed settings. Legitimate values for the speed settings vary widely with the interface type, but you can ask an interface what speed it supports with the standard. Syntax. Here we interrogate an interface to determine support speed and then hard code a desired speed into the configuration. Speed, okay, speed, force enable auto speed configuration. The problem with hard coding speed is that if you change your hub or switch without changing the router settings, your Ethernet interface may either stop working or perform suboptimally. Much like the duplex settings, if you hardcode a speed, the router will refuse to fall back to a degraded mode. There's nothing quite like tracing a troublesome network issue down to an obsolete hardcode network speed. It makes me ask, who was the idiot who said setting? I recommended leaving duplex in auto the default. Okay. 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 And disabling broadcast ping. The IP stop address in every network. The address ending in for a network with netmask is a broadcast address. Traditionally, a ping to that address makes every machine on that network respond. While this was useful for troubleshooting and maintenance, network attackers discovered that they could use this to create one of the first distributed denial of service (DDoS) attacks. Today, it's generally considered wise to disable your router's ability to relay these redirected broadcast pings from the local network. Okay. Okay, no IP directed broadcast. No IP Okay, I can change this setting. Multicast routing cage. By default, modern six-page version enable a routing cage for multicast networking, which will improve performance for multicast routing operation. However, they then disable this cage in the default configuration. I'm sure they have a good reasons for not just disabling it by default really. This show up in your configuration as no IP route cage. If you are using multicast routing, get rid of this configuration statement. The answer to any question that starts with who was the idol is usually me. Okay. And serial interfaces is for the next one. Thank you for watching.